Welcome to the first year of mechanical engineering. This course will lay the foundation for your understanding of mechanical systems, materials, and the principles that govern their behavior. Let's dive into an overview of what you will learn and the prerequisites you should be familiar with. In this course, we will cover mechanics, materials science, thermodynamics, and fluid mechanics. Each of these topics is crucial for a comprehensive understanding of mechanical engineering. Mechanics is the branch of physics dealing with the motion of objects and the forces acting on them. We will cover statics, which is the study of bodies at rest and forces in equilibrium, dynamics, which is the study of bodies in motion and the forces causing such motion, kinematics, which describes motion without considering its causes, and kinetics, which studies forces and torques and their effect on motion. Newton's second law states that the force acting on an object is equal to the mass of that object times its acceleration. The formula is F equals ma, where F is the force, m is the mass, and a is the acceleration. Understanding the properties of materials is crucial for designing and manufacturing mechanical components. We will explore material properties such as strength, ductility, hardness, and toughness, the relationship between stress and strain, and failure theories that explain how and why materials fail under various conditions. The stress and strain relationship for a linear elastic material is given by Hooke's law. The formula is sigma equals E epsilon, where sigma is the stress, epsilon is the strain, and E is the Young's modulus of the material. Thermodynamics is the study of energy, heat, and work. Key concepts include the first law of thermodynamics, which deals with energy conservation, the second law of thermodynamics, which involves entropy and the direction of natural processes, and thermodynamic cycles, which are processes that convert heat into work, such as the Carnot cycle. The first law of thermodynamics for a closed system is expressed as delta U equals Q minus W, where delta U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. Fluid mechanics deals with the behavior of fluids, both liquids and gases, and the forces on them. We will cover fluid statics, which is the study of fluids at rest, fluid dynamics, which is the study of fluids in motion, and Bernoulli's equation, which relates pressure, velocity, and height in a moving fluid. Bernoulli's equation for an incompressible frictionless fluid is given by the formula P plus 1/2 rho V squared plus rho GH equals a constant. Here, P is the pressure, rho is the fluid density, V is the fluid velocity, and H is the height above a reference point. Before diving into these topics, it's important to have a solid understanding of mathematics, physics, and chemistry. These subjects will provide the necessary foundation for understanding mechanical engineering concepts. Mathematics is the language of engineering. You should be comfortable with calculus, including differentiation and integration, partial derivatives, and multiple integrals. Linear algebra, which involves vectors, matrices, and systems of linear equations, and differential equations, including ordinary differential equations and basic partial differential equations. The derivative of a function f of x with respect to x is given by the formula df over dx. This represents the rate at which the function f changes with respect to the variable x. A good grasp of basic physics principles is essential. This includes classical mechanics, which covers Newton's laws of motion, work, energy, and power, electromagnetism, which involves the basic concepts of electric and magnetic fields, and waves and oscillations, which includes simple harmonic motion and wave propagation. The kinetic energy of a moving object with mass m and velocity v is given by the formula Ke equals 1/2 mv squared. Here, Ke is the kinetic energy, m is the mass, and v is the velocity. Understanding the basics of chemistry will help in materials science and thermodynamics. Key concepts include atomic structure, which involves elements, compounds, and chemical bonds, chemical reactions, which cover balancing equations, reaction rates, and equilibrium, and thermochemistry, which deals with heat transfer in chemical reactions. The ideal gas law relates the pressure, volume, and temperature of an ideal gas. The formula is PV equals nRT, where P is the pressure, V is the volume, T is the temperature, N is the number of moles of the gas, and R is the universal gas constant. By mastering these prerequisites, you will be well prepared to tackle the exciting and challenging world of mechanical engineering. Let's get started.